Hello, in this video we're going to be talking about the atomic mass, and this is the number that's found on the periodic table that has decimal places. So if we take an example of carbon, carbon has an atomic mass of 12.01, and those are going to be in units of AMUs, atomic mass units. And so every element on the periodic table, if we look at the periodic table, we can see what their atomic mass is. Now, how do we figure out what their how do we figure out where those atomic masses came from? Well, we're going to be using a weighted average to calculate the atomic mass of each of those elements. Now, you may remember that concept of a weighted average because that is how the grade in this class is calculated. And we covered this during the first week of the semester of how to calculate your grade using a weighted average. So the actual equation for atomic mass goes something like this. So the atomic mass of a given element is equal to the percent abundance of isotope A divided by 100% times the atomic mass units of isotope A. Now, we'll talk about what these are after I finish the equation. We're going to add to that the percent abundance of isotope B divided by 100% times the atomic mass unit of isotope B plus ... as many isotopes as are present. So we know that a given element, let's say carbon, can be either carbon 12, carbon 13, or carbon 14. Each one of those are isotopes. And if we were to take a sample of carbon, a certain percentage of that is going to be carbon 12, a certain percentage is going to be carbon 13, and a certain percentage is going to be carbon 14. Okay? Those certain percentages for every sample here on planet Earth of carbon, carbon 12, carbon 13, carbon 14, are where these percent abundances come from, and these are an experimental value. So these will most likely be given to you unless you're solving for it on a quiz or an exam. So the percent abundance is the relative abundance of this isotope within a given sample of the element itself. We're going to multiply that by the atomic mass unit. So this is also an experimental value where we weighed the atomic mass unit of isotope, let's say carbon 12. So this would be the percent abundance of carbon 12 divided by 100% times the atomic mass unit of carbon 12. So we can do that experimentally. If we were trying to figure out the atomic mass of carbon itself, we would do that isotope 12. We would then add to that the percent abundance of carbon 13 divided by 100% times the atomic mass unit of carbon 13 plus the percent abundance of carbon 14 divided by 100% times the atomic mass unit of carbon 14. And when we add up all those numbers, we would get the number that's on the periodic table. We would get 12.01 AMU. So this is the general equation for figuring out the atomic mass of any element that's on the periodic table. We'll be doing a lot of problems like this in class, but I just wanted you to be aware of what the equation is and how those numbers on the periodic table come to be. Now remember, atomic mass is not the same thing as mass number. The mass number is the number of protons plus the number of neutrons. Atomic mass is this equation. Very, very different ideas. Atomic mass will generally have decimal points. Mass numbers cannot have decimal points because we're only counting protons and neutrons, so it's only going to be a whole number. So there's a difference between those two ideas, even though they sound very similar. Mass number, atomic mass. So with that, I just wanted to give you a general idea of or give you a general rundown of what the idea is of atomic mass, and I will see you all in class tomorrow.